Hello. So to continue on in my series going over Maxwell's equations, I'm going over the second Maxwell equation, commonly referred to as Gauss's law for magnetism. And I anticipate that this will be a rather short video, which you will see why. So in differential form, Gauss's law for magnetism is that the divergence of the magnetic field is equal to 0. And in integral form, it is that the surface integral of b dot ds is equal to 0. So this is saying that the magnetic flux through a surface is equal to 0, and the divergence equal to 0. Well, both of these taken together basically mean that there's no such thing as a magnetic monopole. So unlike in an electric field where a charged particle um, just radiates outwards or inwards depending on the charge, in a magnetic field that system is not possible, meaning that there must always be sort of a north and south pole when you're dealing with magnetic fields that always come back together. So that's saying that the magnetic flux through a surface is always equal to 0, that the divergence equals to 0. It can't just go outwards or inwards, it must always come back. So that was a pretty short video, but I hope that it clarified what Maxwell's second equation, or Gauss's law for magnetism, is. And I hope that you enjoyed the video. If you have any questions or suggestions for future videos, please comment below. It would be much appreciated. Thank you.